Hello everyone, I'm Marcos, the solo developer of Dawn of the West, a multiplayer first-person shooter based on the Wild West. In this episode, we're gonna talk about the process of translating Gasp, the game animation sample, from blueprints into C++. I'm also gonna show you how and why I rewrote the entire shooting system to better fit the game needs. So, let's get started. Gasp, while marketed as an animation showcase, under the hood it contains a significant amount of gameplay logic, all implemented in blueprints. I won't go too deep on how Gasp itself works, it's complex, but here's a high-level breakdown. It's made up of two major parts. First, there's the animation side, which relies heavily on post-search databases for all the different types of movements in the system. Second, there's the gameplay logic, mostly living in the character and animation blueprints. For now, I focused on converting just the character blueprint to C++. I might tackle the animation blueprint later, but that's a rabbit hole for another day. The actual process of translating to C++ was surprisingly chill, at least at first. I took it piece by piece, grabbed a minor feature or part of a function from the blueprint, rewrote it in C++ and tested it by calling it back from the blueprint. This way I could catch issues early and make sure I didn't accidentally break the whole system just by misplacing a semicolon. Half the time it kinda felt like cheating, just finding the C++ equivalent of a blueprint node and calling it a day. Take movement input for example, it's basically a one-to-one copy. Get blur input and pass it to add movement input and boom, game dev magic. But then you hit something like the jump function. This thing is wild. At first it's simple. Is the character doing a traversal? No? Okay, jump. But then, if it is doing a traversal, it starts going down a chain of nested checks, extra functions, special states. Translating that took some real focus. I basically dissected node by node like a mad scientist reconstructing Frankenstein's jump logic. Eventually, it all clicked, or almost all of it. Hello guys, Marcos off script here. I just want to show you a couple of issues I'm still having with Gasp's traversal system. The first one is like this. I've just opened the project at first starting the engine, and if I try to do a traversal, this happens. See? This little hiccup? Yeah, this has been happening since the very first time I've translated the whole system into C++, but if I try it again, it goes, everything smoothly. I kinda have a feeling it has something to do with the database being loaded, but that doesn't happen in the original system in blueprints. So yeah, I'm not sure what could be causing this. The second issue is if I try to do several traversals in sequence, this starts to happen. See? It got stuck, it's not as fluid as it should be, and it gets worse in this last part. If I go in once, it gets stuck and doesn't go to the top of the last one. This second issue wasn't happening at first. It started after I've done multiple changes to the project, after I progressed a little bit, and I'm not sure what broke it. Please leave a comment down below if you have any idea of what could be causing this. But that's enough nerdy stuff. Let's talk about characters, specifically getting my own characters to work with Gasp. Originally, the system was designed only for the UFN mannequin, which makes sense since Epic Battle tests everything in Fortnite. But when they shipped Gasp for UE5, they added this runtime retargeting full body animations at runtime. That has to eat performance, right? Anyway, I gave it a shot. At first it looked okay, but then I started adding weapons and complex animations, and that's when I noticed the finger misalignments. Yep, not ideal, especially in first-person games. I tried a bunch of different fixes, including manually retargeting the animations. Nothing really worked until I found one method that did. I started transferring the animation master pose directly from the mannequin to my metahuman. This gave me properly aligned fingers, but introduced the slight distortions elsewhere because of bone size differences between the two skeletons. To solve that, I added a post-process animation blueprint to the mannequin, which I used to correct the bone transforms so the pose and bone positions look more natural. And one more thing, to get a clean first person view, I duplicated the skeletal meshes for arms and legs. They don't need to align perfectly with the third person model, they just need to look good from the player's perspective. Now, this is pretty much standard practice while setting up FPS characters, but I wanted to mention it because I know it's kinda amazing the first time you see it, right? Now let's talk about the shooting system. Remember how I mentioned in the first devlog that I was using FPS core as my starting point? Well, even though I had a fully working replicated FPS setup, I ended up rewriting it from scratch again. Why? Because first, I wanted to get rid of systems that I didn't need, and FPS core was built around a lot of features I wasn't using. And second, I needed to tailor every bit of the system to fit the game's needs. And although most of the system is completely rewritten, you can still see some of FPS core's DNA in there. I kept the basic structure of the weapon system, mainly the data-driven approach, but several changes were made to the code base. In one of those changes, I was able to introduce a new feature that allows me to create really cool bullet hits effects, which I'll show you in future devlogs. In the end, it was all worth it. The shooting feels way better. It's snappy, responsive, and integrates perfectly with Gasp. So that's it for this devlog, guys. If you found any of this helpful, interesting, or at least mildly entertaining, hit that like button and consider subscribing. You don't wanna miss our next episode where I'll be diving into the new weapon animations and effects I've been working on. Thanks for watching, and I'll see you on the next one.